For a super heterodyne receiver, intermediate frequency is given as 15 megahertz. If intermediate frequency is 15 megahertz and frequency of local oscillator is given as 3.5 gigahertz. Frequency of local oscillator is 3.5 gigahertz, means 3500 megahertz. Now, if the frequency of the received signal is greater than the local oscillator frequency, the frequency of the received signal Fc, this is greater than local oscillator frequency, then we have to find out image of this frequency. So in super heterodyne receiver, we know that the intermediate frequency is, this is modulus of frequency of local oscillator minus the carrier frequency or the frequency of station. Now intermediate frequency is given as 15 megahertz. This is modulus of the frequency of local oscillator is 3500 minus Fc. Okay. Now it is given that the frequency of the signal is greater than local oscillator frequency. It means Fc is greater than 3500. So if Fc is greater than 3500, this quantity will be negative, and if you will take a negative quantity out of modulus, there will be a minus sign to make it positive. So 15 will be equal to, if you take out of modulus, there will be a minus sign because this quantity is negative, minus Fc. So from here Fc is 3515 megahertz. This is the signal frequency, and it is greater than frequency of local oscillator. Now if here we have a modulus, there will be two values of Fc. One will be greater than, one frequency or one value of Fc will be greater than the frequency of local oscillator, and other will be less than Fc. So the frequency of signal is greater than, so the other value of Fc, which is less than the frequency of local oscillator, will give you the image frequency of this Fc. Okay, so if Fc is lower than frequency of local oscillator, this quantity will be positive. So we will write FIF will be, since this quantity is positive, we know while taking out of modulus there is no need to add a negative sign, minus Fc. FIF is 15, frequency of local oscillator is 3500 minus Fc, or let us represent it as Fc dash. This is an image frequency, so Fc dash will be 3500 minus 15, this will be 3485 megahertz. This is the answer. An analog baseband signal is band limited to 100 Hz and it is sampled at Nyquist rate. So the sampling frequency will be 2 into the maximum frequency content of baseband signal. So the sampling frequency will be 200 Hz. It is sampled at Nyquist rate. The samples are quantized into 4 message symbols. There are four quantized levels that occur independently with probability P1 equal to P4 equal to 0.125, and the total probability will be equal to 1. P1 plus P2 plus P3 plus P4 will be equal to 1. P1 is 0.125, this is also 0.125, and these two are equal. So P2 equal to P3, this will be equal to 1 minus 2 into 0.125 divided by 2. This will be 3 divided by 8. So we have probability of all the message symbols, and these message symbols occur independently. So we have to find out the information rate of the message source. We have to find out information rate in bit per second. So information in terms of bit, information in terms of bit, this is nothing but entropy of the source. Entropy of the source. We have 4 possible message symbols with probability of each symbol is given. So we have to first find out the entropy of the source, and entropy in bit per second will give you the information rate. So entropy H is equal to summation Pi log base 2 1 upon Pi. So this will be, first probability is 0.125 log base 2 1 divided by 0.125, and P4 is same, so we will multiply it by 2 plus, now for P2 and P3 the probability is 3 by 8, so 3 by 8 into log base 2 8 by 3, and same will be the case for P3, so we will multiply it by 2. This will be 0.25 into, this will be 8, log 8 will be 3 plus 3 by 4 log 8 by 3 base 2. This will give you 1.811. So this is entropy of the source, and entropy is also, this is, entropy is nothing but the minimum number of bit required, or the average number of bit transmitted per symbol. Entropy is nothing but, entropy is average number of bit transmitted per symbol, and this will be the information. The information transmitted will be nothing but the average number of bit transmitted per symbol. Okay, so for one symbol 1.811 bits are transmitted, but we have to find out number of bits transmitted in 1 second. The sampling frequency is 200 Hz. So in 1 second 200 symbols will be generated. In 1 second 200 symbols will be generated, and one symbol is represented by, on an average, 1.811 bit. So 200 symbols will be represented by 200 into 1.811 bit. Okay, and these 200 symbols are generated in 1 second. So in 1 second 200 into 1.811 bits, on an average these many bits have to be transmitted. This will be 362.3 bit per second. So in this question, what we did, we first found out entropy of the source, and entropy of the source is 1.811, and entropy is also the information content in one symbol. Entropy is nothing but information content in one symbol. in this question the graph of or the formula of pulse PT is given. We have PT given and we have to find out the graphical representation of the matched filter output. This PT will be first given to matched filter of PT HT, and then we have to find out the graph of output YT. So what will be the formula for matched filter of PT? HT will be nothing but P TS minus T. Okay, and what is PT? The graph of PT is, it is non-zero for the range of Ts starting from 0. It starts from 0 and this is non-zero up to a width of Ts, and this height is 1 by root Ts. Okay. So now let us find out the shape of matched filter, the impulse response of matched filter HT. HT is nothing but Pts minus T. So if we have the graph of PT, what will be the graph of, first we will do the shifting and then scaling. So PT is given, then what will be P T plus Ts. We will shift this graph, since we are adding Ts, we will shift this graph by Ts unit to the left hand side. So if we will shift this Ts unit to left hand side, the point Ts will be at 0, the point 0 will be at minus Ts. This is the graph of P T plus Ts. Now we have to do the scaling. We have to multiply in the variable with -1, or in the variable we have to add minus sign. So while doing that, we have to take the mirror image of graph about y-axis. So if we will take the mirror image, this will be 0 will be 0 and minus Ts will become plus Ts. Okay. So this graph is P Ts minus T or HT. Okay. In the question we have to find out graph of YT. So YT is nothing but convolution of PT with HT, or convolution of this graph with this graph. Although these two graphs appears to be same, but their formula are different. Let us make a cap here, or let us denote a point A here. So when you shifted this graph, where will be the point A? This point will be simply shifted. Okay, this point has been shifted, so this point is here, so A will be here. Now when you will take mirror image, where will be the point? This point is A is here. So although these two graph appears to be same, but if you compare the position of point A, this is different. So if this graph is PT, this is not PT, this is PTS minus T. And due to symmetry, the graph is symmetrical from this point to this point. Due to this reason, these two graphs appear to be same. Okay, now we have to find out convolution of this graph with this graph. 0 to Ts convolution, 0 to Ts. Okay, so we have already found out in signal system, in the lectures of signal system, we have already found out the convolution of these two graphs many times. The convolution of these two graphs will be, if we are taking convolution of two graphs, the overall width of the answer will be, the overall width or the overall range for which this graph will be non-zero will be width of this graph plus width of this graph. So the total width is 2Ts So this graph will be non-zero for, or the width of the graph in answer will be 2ts. So in this option the total width of graph is ts, so this option will be wrong. And when you will take convolution, the graph will look like this. And if you want to find out the maximum value of yt, the maximum value of yt will occur at ts. Let us write expression for yt. Yt will be pt convolution p ts minus t, integration minus infinity to plus infinity p tau into p. Here at the place of t we will put t minus tau, so ts minus t minus tau d tau. This is equal to minus infinity to plus infinity p tau p ts plus tau minus t d tau. Now if you are interested to find out the value of y at t equal to ts, at the place of t we will put ts. Here also at the place of t we will put ts. So ts and ts will be cancelled, p tau and p tau. We will have p tau square d tau. So p tau square d tau is nothing but the energy of the signal pt. In communication system we have studied that if pt is transmitted at receiver end after passing through the matched filter ht, the instant of detection is ts. So the value of output at ts is nothing but the energy of the signal pt. Value of the yt at t equal to ts is nothing but energy of the signal pt. This we have already studied in communication system. Okay. And what is the energy? P tau square is, this is constant at 1 by root ts. So this will be 1 by square of 1 by root ts is 1 by ts, and since this is constant, so this will be taken out of integration 1 d tau, and this is non-zero from 0 to ts. So instead of this limit we will use 0 to ts. This will give you 1. So the energy of this signal is 1, that occurs at t equal to ts. So this value is 1. Okay. So this option will be correct. If you are interested to find out the complete graph yt, so you may take convolution to find out the convolution. There are many methods. One method is formulate this graph. This graph is ut minus ts convolution. This is also ut minus ts. Okay. So convolution of ut and ut will give you tut. Then convolution of this with ut gives you tut. Here is a delay of ts. So in the answer also there will be a delay of ts. And same will be the case when you will multiply this ut with this ut minus ts. So one more term will be added, and when you will take convolution of these two functions, you will get t minus 2ts ut minus 2ts. This will be the yt. There will be 3 ranges for which yt can be broken: t less than 0, you will get yt is equal to 0. If t is greater than 0 and less than ts, yt will be, if t is greater than 0, this will give you t, and if t is less than ts, this will give you 0. This will also give you 0. So yt equal to t. So from 0 to ts you have yt equal to t. For t greater than ts and less than 2 ts, yt will be, this will give you t minus 2 into, since t is greater than ts, so here you will have greater than 0 and this quantity will be 1, minus 2 ts. So this is ts minus t. So for the range t between ts to 2 ts, the graph is, the equation of this line is ts minus t. And when t is greater than 2 ts, yt will be, when t is greater than 2 ts, this will give you 1. All these unit step functions will give you 1. So this will be t minus 2 into t minus 2 t minus ts minus, this is not minus, this will be plus here, this minus and this minus will be plus, t minus 2 ts. Here also this will be 2 ts minus t. So if you will calculate it, you will get it as 0. So for t greater than 2 ts, yt will be 0. There is another method to differentiate one function. You will get impulse here, then taking convolution of this rectangular pulse with 2 impulses will be very easy, and after taking convolution, then you again integrate the answer, then you will get the final answer, as we did in signal system. Autocorrelation function of xt is represented as Rx. So Rx tau will be, Rx tau is nothing but average of xt into xt minus tau, or average of xt minus xt into xt minus tau. And yt is given in terms of xt. Yt will be, here we have xt and here we have xt, but with a delay of t naught. So here signal will be xt minus t naught. So yt will be xt plus xt minus t naught. So autocorrelation function of xt is given and yt is represented in terms of xt. So we have to find out autocorrelation function of yt in terms of autocorrelation function of xt and the delay t naught. So if we try to write down the expression for autocorrelation function of yt, this will be ryt is, or ry tau is, this is nothing but mean of yt into yt minus tau. This is formula for autocorrelation function, average of yt into yt minus tau. Instead of minus, we can use plus also. Autocorrelation function is an even function. Okay. Now what is yt? Put value of yt in terms of xt. We have to find out xt plus xt minus t naught into, now yt minus tau. So in xt, in this expression, at the place of t, we will put t minus tau. So this will be x t minus tau plus x. At the place of t we will put t minus tau and t naught will be as it is. So now we have to find out average of this multiplication. I did nothing. In this expression, at the place of yt I put xt plus xt minus t naught. Now we have to find out average of this quantity. Average is a linear operation, so first multiply and take individual averages and then add. So first we will multiply it, this into this, xt into x t minus t tau, then this into this, xt into x t minus tau minus t naught, then this into this, xt minus t naught into x t minus tau plus xt minus t naught into this xt minus tau minus t naught. So now we have to take average of this quantity, take individual averages and add it. So what is this expression? This is nothing but the expression for autocorrelation function of xt. So this is Rx tau Now, how we will represent this quantity in terms of Rx tau? Rx tau is defined as 1 by t integration over t xt into x t minus tau dt, or average of xt into x t minus tau. Okay. Now at the place of tau, if we put tau minus t naught, so we will have Rx tau minus t naught will be in this integration also. This integration is done in terms of t, so tau will be a constant here, and at the place of tau we have put tau minus t naught, so this will be 1 by t xt into x t minus tau minus t naught, now dt. This is 1 by t integration over t. If this is not periodic with t, capital T will tend to infinity. This will be t plus t naught minus tau dt, or this is again average of multiplication of these two quantity, average of xt into x t plus capital T naught minus tau. But here we have t plus capital T naught, and here we have t minus capital T naught. So at the place of tau, if we put tau plus T naught, then what will happen? Here we will have tau plus T naught, and now we will have negative sign. Now T naught will be negative, and here T naught will also be negative. So this is Rx tau plus T naught. This quantity is nothing but Rx t plus T naught. So this quantity is Rx tau plus T naught. So this is done, this is done. Now we have to take average of this quantity. So again we will use this expression. Let us put the limit from 0 to t, and in this expression substitute t equal to t minus t naught. So here we will have 1 by t. Let us put t is equal to t dash minus t naught. So when t is equal to 0, t dash will be t naught, and when t equal to capital T, t dash will be capital T plus t naught. Okay. So again the range of the limit is again capital T only. If you subtract t naught from the upper range, t naught will be cancelled, t naught and t naught will be cancelled, and again you have the overall range of integration is capital T. So this can again be written as capital T. Here you have t dash minus t naught x t dash minus t naught minus tau d tau. Or let us do this way. We have to find out average of this quantity. So this will be 1 by t integration from 0 to t x t minus t naught into x t minus tau dt. Now put t minus t naught equal to t dash. So this will be 1 by t. When t is equal to 0, t dash will be minus t naught. When t is equal to capital T, t dash will be capital T minus t naught. This will be x t dash, t minus t naught equal to t dash into x. At the place of t, we will have t dash plus t naught. And dt will be equal to dt dash. 1 by t. Again, the range of the integration is, if you subtract lower limit from upper limit, minus t naught and minus t naught will be cancelled, and the range of integration will be capital T. This is x t dash, x t dash. Now this can be written as minus tau minus t naught dt dash. Okay. Now this expression is in the form of autocorrelation function. Since this is a definite integral, the name of variable can again be changed to t. Okay. So xt into xt minus, at the place of tau, what we have, tau minus t naught. So this is nothing but autocorrelation function, and at the place of tau, what we have, tau minus t naught, tau minus t naught. So this expression is nothing but Rx tau minus t naught. Similarly, for this expression, we have to find out average of this quantity. 1 by t integration from 0 to t xt minus t naught into xt minus tau minus t naught dt. Again put t minus t naught equal to t dash, and as we did in earlier case, limit will first change. We will first put 0 to t, then we will change the limit, and again we find that the overall range of integration is capital T only. T minus t naught is t dash x. At the place of t, we have t dash plus t naught. So we will put t dash plus t naught minus tau minus t naught dt dash. This is 1 by t x t dash x, t naught and t naught are cancelled, t dash minus tau dt dash. and this is nothing but average of xt into xt minus tau, and this is rx tau only. So the fourth expression is nothing but rx tau. So we have here 2 rx tau, okay, plus rx tau plus t naught plus rx tau minus t naught. Okay, according to this question, this answer is correct, but originally in the question here this is negative sign. Okay, I took summation of these two signal, but originally in the question we have negative sign here. So to modify, what we will have, yt equal to xt minus t naught. So here also we will have minus sign, this is minus sign. Okay, first term will be positive, second will be negative, third will be negative, and fourth will be positive. So here also this term will be negative, this is negative, and the fourth term is positive. So this will be minus, and this will also be minus. So according to question, B option will be correct. Here the bandwidth of the channel is given as 4 kilohertz. Bandwidth of the channel is 4 kilohertz, and bit rate is given as 52 kbps. RB is 52 kbps, means 52,000 bit per second. And with this rate, the signal has to be transmitted over this channel with arbitrary small bit error. So if you want information at this rate to be transmitted over this channel of bandwidth 4 kilohertz with arbitrary small error, the channel capacity has to be greater than the bit rate, and the formula for channel capacity is bandwidth log base 2 into 1 plus log base 2 1 plus signal to noise ratio, means signal power divided by total noise power. If you want this information to be successfully transmitted through a channel of 4 kilohertz, then the capacity of channel, this has to be greater than the bit rate, and this is formula for capacity. Okay, so first we will find out the minimum capacity has to be, if capacity is greater than bit rate, the minimum capacity, or simply we will write this quantity has to be greater than bit rate RB. So using this condition, bandwidth is given, signal to noise power, the noise power we will find out with the help of noise power spectral density. Noise power spectral density is the two-sided power spectral density is given as 2.5 into 10 to power minus 5 watt per hertz, and the bandwidth is 4 kilohertz only. So this will be truncated at 4 kilohertz and minus 4 kilohertz. So the total noise power N naught will be area of the power spectral density between minus 4 kilohertz to plus 4 kilohertz. So this area will be 2.5 into 10 to power minus 5 into this width is 8 kilohertz, means 8000. So this will give you 0.2 watt. So we have noise power here, bandwidth is given, and a condition is given. So first we will find out signal power. The bandwidth is 4 kilohertz, 4 into 10 to power 3 log base 2 1 plus s divided by n. This has to be greater than 52 kbps, means 52 into 10 to power 3, or log base 2 1 plus s by n. This has to be greater than 30. Now if log base 2 of a quantity, if this is greater than 13, we can represent it as 1 plus s by n has to be greater than 2 to power 13. It means that this quantity is very large and 1 is fixed, so the value of s by n will be much greater than 1. So approximately we can write it as s by n has to be greater than 2 to power 30. N is equal to 0.2, so signal power has to be greater than 0.2 into 10 to power 13. If this quantity has to be greater than 0.2 into 10 to power 13, it means that the minimum value of signal power has to be 0.2 into 10 to power 0.2 into 2 to power 13. Okay, so this is signal power, and power is nothing but energy if this power is in watt. Since I have taken n in watt, so s will obviously be in watt, because this quantity s by n has to be unitless. So if n is taken in watt, s will also be in watt. So this is in watt, and power is nothing but energy per second. So we must have 0.2 into 2 to power 13 watt power. It means this much joule energy in 1 second. We will see that in 1 second this joule of energy, this much energy has to be transmitted. Okay, in 1 second this much energy has to be transmitted, but here we have to find out bit energy, the energy in 1 bit. What we have to find out? Energy in 1 bit. And in 1 second how many bits are transmitted? 52,000 bits are transmitted. These many bits has to be transmitted, and in 1 second this much joule has to be transmitted. So we can say that 52,000 bits must have 0.2 into 2 to power 13 joule energy. So 1 bit will have 0.2 into 2 to power 13 divided by 52,000 joule energy. In 1 second these many bits are transmitted, and in 1 second this much joule energy is transmitted. It means that 52,000 bits, these many bits have to contain this much energy. So 1 bit will contain this energy divided by 52,000. If you multiply it with 1000, this will give you in millijoule. 0.2 into 2 to power 13 divided by 520. No, 52. This is 31.5 millijoule. So 1 bit must have 31.5 millijoule energy. It means that energy per bit, the minimum bit energy will be 31.5 millijoule. In this question, the probability of bit error is, it is given as 10 to power minus 5. So the probability of correct detection will be, let's say PC represent the probability of correct detection of a bit. This will be 1 minus 10 to power minus 5. Okay. Now the question is 10 to power 5 bits are sent over this channel, then the probability that not more than 1 bit will be in error. We have to find out probability that not more than 1 bit is in error. We have to find out probability of this condition. So it means that not more than 1 bit is in error. It means that we have to find out probability of no error, okay, and you should not have more than 1 bit in error. It means that 2 bit cannot be in error, but 1 bit can be in error and 0 bit can be in error. These are the two cases. So we have to find out the probability of, or the summation of probability of these two cases. So we have to find out probability of no error and probability of when the exactly 1 bit is in error. Exactly 1 bit in error. For these two cases, find out the probability and add them. Then this will give you the probability that not more than 1 bit is in error. So for probability of no error, there are 10 to power 5 bits. It means there are 1 lakh bits and all are detected correctly. Okay, and this is memoryless channel. It means that if 1 bit is detected correctly, it has nothing to do with the next bit. This may be correct or incorrect with this probability. Now the next bit will be again correct or incorrect with the same probabilities. The next bit or the detection of the next bit, it has nothing to do with the detection of the previous, or it has nothing to do with the detection of previous bit. So all 10 to power, all 1 lakh bit has to be detected correctly, and the probability of correct detection is 1 minus 10 to power minus 5. So if 1 bit is, the probability that 1 bit will be detected correctly is 1 minus 10 to power minus 5. Similarly, for second bit also, the probability of correct detection is this, and simultaneously all bits have to be detected correctly. So we will multiply it with the same quantity 1 lakh times. So we have to find out 1 minus 10 to power minus 5 to power 1 lakh, or 1 minus 10 to power minus 5 to power 10 to power 5. So this is the probability that no bit will be in error. Now next, let us find out the probability that exactly 1 bit will be in error. There are 1 lakh bits, and we are dealing with the case when exactly 1 bit will be in error. So first bit may be in errors, or if first bit is in error, remaining all 99,999 bit will be detected correctly. Okay, so there is possibility that first bit will be in error, second bit may also be in error. Similarly, the bit at this position, the last bit will also be in error. So only 1 bit will be in error. In total 10 to power, for bit to be in error, there are 1 lakh positions. Okay. So the number of ways in which only one bit will be in error, this will be 10 to power 5 C1, and this will be 1 lakh. Okay. So first, the probability of error when exactly one bit is in error. This may happen in 10 to power 5 C1 ways, and one bit has to be in error, so we will multiply it with the probability of error, and there is only one bit, and remaining all bits has to be detected correctly. How many bits are remaining? 99,999 into probability of correct detection, and this has to be multiplied 99,999 times. So this will be 10 to power 5 into probability of error is 10 to power minus 5, PC is 1 minus 10 to power minus 5, and this is 10 to power 5 minus 1. This is equal to 1. So we have to find out 1 minus 10 to power minus 5 into 10 to power 5 minus 1. So this is probability when exactly one bit will be in error, and this is the probability when no bit will be in error. And when we will add these two probabilities, we will get that not more than one bit will be in error. So if you will find it with the help of calculator, this will be 1 minus 0.0001 to power 1 lakh. This is 0.367877, and this is 0.36788812. So when you will add these two probabilities, we will get, adding these two probability will give you the probability when not more than one bit will be an error, and this is 0.735758. So this will be the answer. I am not sure that whether the calculator given in examination can do this much of calculation, because we have to find out, this is a quantity very close to 1, and we have to find out, we have to multiply this quantity by itself 1 lakh times. So I am not sure whether that calculator can calculate it or not. So to calculate it, we can use the concept of limit. If you are required to find out this quantity, we can write it as 1 minus x. Let x is equal to 10 to power minus 5. Okay. Then what is 10 to power 5? 10 to power 5 will be 1 by x. So basically we have to find out 1 minus x to power 1 by x, where x is a very small quantity. Okay. Then take limit of x as limit x tends to 0. So we have to find out this quantity, and let this quantity is y. Now take log both sides. Now ln y will be 1 by x ln 1 minus x limit x tends to 0, or ln 1 minus x divided by x and x tends to 0. Now if x will tend to 0, here you will have 1, and ln 1 is equal to 0. So in the numerator you have 0, and in the denominator x itself tends to 0, so this is also 0. You have a form of 0 by 0, so we will use L'Hospital rule. We will differentiate numerator and denominator. So ln y will be, we have to find out y. So first we will find out ln y and then y. So if you will differentiate it, you will get differentiation of ln will be 1 upon 1 minus x, and differentiation of minus x will give you minus 1, divided by x here is, differentiation of x is 1, and again limit x tends to 0. So ln y will be minus 1 divided by 1 minus x, x tends to 0. Now if x tends to 0, this is very small quantity, so this x will be neglected in terms of in front of 1. So ln y will be minus 1, so y is equal to e to power minus 1. And e to power minus 1 is 0.637879. It is approximately equal to what we have calculated with the help of scientific calculator. The difference comes after 3678 after 4 digits. Similarly, you can calculate in the probability of exactly 1 bit in error. What we had 10 to power 5 into 10 to power minus 5 into 1 minus 10 to power minus 5 to power 99,999. This was 1, let this is x, and this will be 10 to power 5 minus 1. So if 10 to power minus 5 is x, 10 to power 5 will be 1 by x minus 1, and limit x tends to 0. This is y. Now as we did in this case, you use the same procedure, take log both sides, you will again get a form of 0 by 0 and differentiate numerator and denominator. So again you will get y as e to power minus 1 if x tends to 0. Okay, and by adding these two probability you will get the answer.